Okay.
Are you serious? Listen, send that to that woman and send that picture we took outside with all of us in it where I was held up and had my face in there too.
Yeah, the picture's being
Send that one and then to that woman and we'll be doing good.
Outsiders. Caleb is teaching.
Smile, Mr. Smith!
Caleb is teaching the
Okay.
class Carvin, get over here.
See this?
Yeah.
That and your calculator is the only thing you need to solve a two-parameter model for a power function. And of course, that's also equal to natural log of x over the natural log of b. And of course, log x, or log b of x equals c is equivalent b to the c equals x. And I probably shouldn't have used x there. So maybe I'll change my name of my variable to see if this fancy chalk stuff that I just used for the first time. So I'm going to change x because you could confuse that with an equation.
Is that log base b
In X.
equals log of
Stuff
something?
gets a little messy. Okay, just testing this stuff out a little bit. Okay, so it's going to get a little sloppy here, but we'll deal with that. Okay. So you have log base b of a. Doesn't really matter what letters you use, but it's probably better. To use letters that you wouldn't confuse with variables that you would typically have in an equation. Okay? So if we get down to, for example, 5/7 to the p equals 3, how do we solve the equation? Well, this is in this form, right? And this form can be translated to this form, which can then be solved, at least approximately, on a calculator using this. And there's no alternative to the calculator unless you want to do a really tedious Taylor expansion, okay? Yeah, there are actually other alternatives, but that's a little straightforward. So how does this translate? How do you fill in the blanks here? Yeah.
Log base 5/7 of 3 equals p.
Yeah. Just using this rule. There's p. So p equals log base 5/7 of 3. And now, according to this rule that I just kind of bestowed upon you, we could do it starting with the inverse of the graph of 2 to the x. And we could explain it, but we don't have time, so we're just going to take that as handed down on a stone tablet for the moment, okay? So, if you use this to express this, how do you get something you can put into your calculator and solve?
Log of 3 over log of 5/7.
Yeah.
Or you can just, I know my calculator has a log base key. I don't know if anybody else.
Mine does too.
Alright.
It has a log base too?
Yep, you go right over here, you hit on.
That's good, because that's the other number. It makes sense to use a log base. Now, if you're doing calculus, you're always going to use log base e, which is a natural log.
If you can get, I don't know if anybody else has it. I know you have it, and I have it. You can
Casey.
get like a log base, so you can put your log base and then your
No, that's
number
cheating,
as well.
but that's okay. For our purposes, I want you to use this translation.
Yes, sir.
Because that translation is going to be real important to you when you start taking derivatives of logs with different bases. And derivatives are just rates of change, just like you draw the graph, that's the slope, okay? It's a rate of change, it's a slope. And the log base B thing on your calculator is not going to help you, and you really need to know the rules, and you got to use the rules.
Yes,
But
sir.
on the other hand, for doing an equation like this, it's kind of valid, but I want you to do this because it'll get you used to something you need to know later. Okay? At least it'll stimulate those neurons, and when you see it later, it'll be a little easier for you. Okay? So you can do that, right? Okay? So you use this in solving the simultaneous equations for an a x to the p. So this is used to solve that in the form y equals a x to the p when you're given 2 points, and that's one of the early things we did. So you'll understand the context, okay? So what this tells us now is that we have at least 3 models that we can solve if we have enough data points. We have the
Used to complete solution for a comma p.
power function model. Y equals ax to the p. How many parameters does this have? Told you a few days ago, but I didn't really ask you to tell me how many. Huh?
4?
Nope. Y and x aren't parameters, those are your variables.
So 1.
No, there's more than 3 symbols in that equation. You have the parameters a and p, which means you're going to need 2 points so you get 2 equations that you can solve. Might have to review what you did a week ago, but it's not going to be totally submerged in your subconscious. You'll remember if you review it a little bit and look back at what you did, because people did okay with this. The only problem people had was maybe didn't remember what to do, so you got to review that because you're going to have to do it. I guarantee you're going to have to do this at least.
So A and P are the two
Well,
variables that
we're
you're
not going to worry about that. I'm giving you the scheme. We've done it. So we're not going to review how you did it. You've got it in your homework. And everybody pretty much did it up to the point where you needed to do this. Okay? Everybody pretty much got down to this point. Okay? So you can get it here. All you need to do to finish it is get the rest of it. And then plug back in and find A.
Are we gonna have problems on this for homework tonight?
Yeah, I'll probably give you practice problems. And give you one review problem and saying, here's what you can do if you want to practice. And you can always check it. You know how to check it. You just plug everything back into the other equation, see if it works. Exponential function. Model. What is it? Y equals what?
2 to the x.
Again?
2 to the x.
You have 2 to the x is your basic exponential function. That's a good answer, but the general exponential function.
A to the x.
Again?
A to the x power.
Now there's no p. It's a times b to the x. That would be like 2 to the x. 2 to the x is one of them, right? If b is 2, it's your basic exponential function. If b is 2 and a is 1, you have the y equals 2 to the x function. Okay? So you got ab to the x. And this one you know how to solve. You don't have to use logs. You just use the laws of exponents. And then you have the quadratic model. And your parameters are A, B, and C. So you would need, you can fit this to 3 data points. Okay? Now if you have 4 data points, there's no reason to expect the 4th will fit with the first 3. That any one of them will fit with the other 3. Okay? Then you got to do something else that goes into pretty deep linear algebra and pretty deep second semester calculus, although it's done in an applied calculus course. Okay? The linear algebra solution is kind of a capstone at the end of a good linear algebra course. Okay? And this is what you do if you do a curve fit on your calculator. If you do a quadratic model, they might say it's a polynomial of degree 2, depends on the system. Excel says polynomial of degree 2. You put the coordinates of any number of points in, it'll give you the best possible parabola that fits those points. Okay? And you can do the same thing with an exponential model or a power function model. You know, spreadsheets, computer software, they all do this. Okay? And the algorithms are not that deep, unless they've been really refined, in which case they can get a lot deeper. Deeper than I know. But the basic way it's done is pretty straightforward. Once, you know, you got commanded linear algebra and calculus, which nobody is expected to do at this point. Okay, so my whole point is, this is a really important scheme for functions that model things out here in the real world. Okay? And that's one of the big things that you do not get in the high school curriculum. And you don't, a lot of college curricula don't do it all that well, but it's very, very important. Okay? You know, college is busy remediating what you didn't get from the secondary school curriculum. Okay? So what you can do in a college course is limited unless you go to a really good university with really high standards, and they're hard to get into. But that's where you want to go if you can, and y'all, I think all of you have the ability to do that. Okay, so that's one of the big schemes of this course. It's the first thing we did, basically. We started out with a pendulum, we got the model, except we couldn't do this, because I just kind of saved this for the end, because it's really a pretty easy step. You just got to practice it a little bit. Okay? So I'm probably going to ask you to go back and complete those pendulum models. You know, solve for P, use and use this. After you've used it once or twice, it's easy. Okay? So that's one of the big deals. Now I've got to look at my paper and see what another big deal is, but yeah, it's long.